everyone, myself Prayak Patel, working as Assistant Professor in IT/ICT Department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the subgraph, complete graph and complement of graph. Now in this unit, we include the topic as a subgraph, then complete graph, then complement of graph, and also we discussed in today's lecture as a null graph. Now in graph theory, what is the subgraph? So here subgraph as a if a graph G equal to VE as a directed or undirected graph, then G1 equal to V1 E1 is called a subgraph of a graph G. If phi not equal to V1 subset or equal set of V and E1 is a subset or equal set of E, where each edge in E1 is incident with vertices in V1. So here basically your graph is a given graph G and your subgraph is a graph G1. Now what is V and what is V1? V means set of vertices of graph and V1 is a set of vertices of a subgraph. Now what is E and what is E1? E means set of edges of your graph and E1 is a set of edges of your subgraph. Now here V1 is a subset or equal set of V, but compulsorily V1 not equal to phi. So if V1 equal to phi, then not considered as a graph, because without any node, no any edges are exist. Then we can say that without any node and without any edges, no any graph is exist. So we can say that V1 not equal to phi is compulsory condition. Now V1 is a subset or equal set of V, means all the vertices of subgraph is also a member of a graph G. And E1 is a subset or equal set of E, means all the set of edges is also a member of the set graph G. So here we can say that this graph is a given graph. In this graph we have a 5 different vertices A, B, C, D and E. Now what is the subgraph for this graph G? So this is a graph 1, subgraph 1 is considered as a subgraph. So here we include the edges like C to D and vertices like A, B, C and D. So here A, B, C and D for member is also a member of your graph. Means in graph what is the V? V means set of vertices. So here set of vertices is A, B, C, D and E. In subgraph set of vertices V1 equal to A, B, C, D. So A, B, C, D is subset of A, B, C, D, E. So this is satisfied. V1 is a subset or equal set of V. Now for the edges, E1 is a subset or equal set of E. So what is E1? E1 means edge CD. And what is E? E means AD, CD, ED and BE. So CD is also a subset of your graph G as a edges C to D. So this is considered as a subgraph. Now second subgraph as a subgraph 2. In subgraph 2 we consider the 3 node B, E and D. These 3 node is also available in a graph. So this is a valid as a V1 is a subset of V. And second thing is edge BE and edge ED is available in your subgraph. So these 2 edges also available in your graph G. So we can say that this is a subgraph. Now in graph 1, in subgraph 1, vertices A and B are considered as a isolated vertices because they are not connected. So A and B as a isolated vertices. Now for the directed graph also we can consider the subgraph. So in this figure graph as a your directed graph. In directed graph we have 5 vertices S, T, U, V and W. Now for this graph, what is the subgraph? So this next figure graph 3, subgraph 3 is considered as your subgraph for the directed graph. So here we include the 4 vertices S, T, U and W and consider the 2 edges from the S to T and V to S. So this is a considered as a subgraph because all the 4 node and 2 edges also available in your graph. So this is a subgraph. Now next definition is a spanning subgraph. Given a directed or undirected graph G equal to VE, let G1 equal to V1 E1 be a subgraph of graph G. So here G as a given graph and G1 as a your subgraph. So subgraph having V1 as a vertices and E1 as a edges. If V1 equal to V, then G1 is called a spanning subgraph of G. Now here we consider G1 as a subgraph, means V1 is a subset or equal set of V and E1 is a subset or equal set of E. But one additional condition here is V1 equal to V, means compulsorily all the vertices in your graph must be included in your subgraph also. So that subgraph is called the spanning subgraph. For example, this graph is a given graph. Now for this graph we have 5 vertices and 4 edges are available. Now for the subgraph 1 consider as a spanning subgraph or not. So for checking that, first you check your subgraph 1 is a subgraph of your graph G. Yes, here this subgraph 1 is a subgraph of your graph G. But also check V1 equal to V, means all the vertices compulsorily included in your subgraph. So here we have A, B, C, D, E vertices in your graph, and also in subgraph 1 we have 5 vertices A, B, C, D, E. Here we include some edges, we cannot include some edges, it is possible, but compulsorily we include all the vertices. So this is considered as a spanning subgraph 1. Now subgraph 2 is considered as a spanning subgraph or not. So for that, first we check all the vertices are available. Yes, A, B, C, D, E are available in your subgraph, and here consider this is a subgraph of your graph G. Yes, then this is also considered as a spanning subgraph of your given graph G. Now for the directed graph also we can represent the spanning subgraph. So this is your graph as your directed subgraph. Now check for the graph 3. Graph 3 consider as a spanning subgraph or not. For that, first check the subgraph 3 is a subgraph of the graph or not. So here we include all the vertices and 2 edges, both are available in your graph also. So this is a subgraph. Now all the vertices are included or not, means we can say that V1 equal to V or not. V means S, T, U, V, W. V1 means also S, T, U, V, W. So V1 equal to V is satisfied, then this graph is considered as a spanning subgraph. Now graph 4 also considered as a spanning subgraph because we include all the vertices S, T, U, V and W, and we include edges, that edges also available in your graph. So this is considered as a spanning subgraph. Now for the spanning subgraph, if this graph is considered as a spanning subgraph, when we check the condition is like, first thing is this graph is a subgraph or not. If this graph is a subgraph, then check the second condition as a V1 equal to V. Now for this graph having the 5 node A, B, C, D, E. Now in a subgraph, first subgraph, we having only 4 element, 4 node A, B, C, D. So we can say that E is remaining. So this graph is not considered as a spanning subgraph. This graph is considered as a subgraph but not as a spanning subgraph. Now last figure also considered as a subgraph but not as a spanning subgraph, because here we include the B, D and E element, we cannot include here A. So this graph is not considered as a spanning subgraph but considered as a subgraph. Now for the directed graph also we check for the spanning subgraph. Now this is a given graph having the 5 element S, T, U, V, W as a vertices and 4 edges are available. Now if we represent this subgraph like S, T, V and W as a vertices and S to T and S to V to S as a edges. So this considered as a spanning subgraph or not. So for that, first we check all the vertices are available or not. So here U is not available in your subgraph. So this subgraph is not considered as a spanning subgraph. Now next consider the induced subgraph. Now definition of the induced subgraph is G equal to VE and H equal to WF are graphs. So here G and H both considered as a graphs. We say H is a subgraph of G. So H is a subgraph of G, then we can say that W is a subset or equal set of V and F is a subset or equal set of E. We say H is an induced subgraph when W subset of V and F equal to XY belongs to E. If here condition is XY belongs to W. So here XY is a one edge and X and Y both element individually considered as different vertices. So X is a one node, Y is another node. If we include the X and Y node in our subgraph, because here W is a set of vertices of subgraph and V is a set of vertices of graph. So W is a subset of V, but here we include in W, we include XY as a two vertices. Then if X2Y edge is available, then compulsorily we include the XY edge in our subset set E as a, we can say that the edge is set E. So here we can say that XY belongs to W or XY is included in our set of vertices. Now another definition of the induced subgraph is, let G equal to VE be a graph directed or undirected if phi not equal to U subset or equal set of V. The subgraph of G induced by U is the subgraph whose vertex set is U and which contain all the edges from G of either the form XY for XY belongs to U where G is a directed graph, or XY for XY belongs to U when G is undirected graph. We denote this subgraph by U. So a subgraph G dash of the graph G equal to VE is called the induced subgraph if there exists phi not equal to U subset or equal set of V where G dash equal to U. So basically induced subgraph means if we want to end the XY node in our graph, then compulsorily we include the XY edge. If available in graph, then compulsorily we add this XY edge in our graph. So this is called the induced graph. Now example of the induced graph is, here graph G as a given graph. Now in part B graph G1 considered as an induced subgraph. So for that here we check. In part B, G1 equal to U1 for U1 equal to B, C, D, E. U1 means set of vertices of your subgraph. So in subgraph G1, set of vertices equal to B, C, D, E. Now, if we include the B, C, D, E in our subgraph, then all the possible combination or available combination of the edges in your graph is also included. So here we include B, C, D, E, then include B, C edge, then C, D edge and CE edge in our subgraph. Then this graph is called the induced subgraph. Now next, in figure C, G2 consider as your subgraph. Then G2 equal to U2 for U2 equal to A, B, E, F. So here A, B, E, F consider as your four vertices of the graph G2. Now if we include the A, B, E, F, then available all the combination of this four node available in this graph G must be included all the edges into the subgraph G2. So here one available is B to A and second possibility is E to F. Only two edges are available for the A, B, E, F. Common edges are these two. So include these two edges. Now for the graph G3. For the graph G3 we check how many vertices are available. So A, B, C, E and F, 5 vertices are available. Yes. Then here we include all the combination of these 5 vertices available edges of your graph G. So here we can say that one edge is AB, another edge is BC, another edge is E to F. Now C to E edge is also available, but here we not included C to E. That's why we can say that this last graph is not considered as an induced subgraph, because here C to E edge is not available. Now here this graph is a given graph and G1 graph is a subgraph. Now another definition of the induced subgraph is, let V be a vertices in a directed or undirected graph G equal to VE. The subgraph of G denoted by the G minus V has the vertex set V1 equal to V minus V and the edge set E1 subset or equal set of E, where E1 contain all the edges in E except for those that are incident with the vertex V. So basically here we can say that the G minus V is the subgraph of G induced by V1. So here this is a given graph. Now for the subgraph G1, here we subtract the C as a vertex. So we subtract the vertex C as a V. So V minus capital V minus small v consider as a V1. So in subgraph, set of vertices equal to A, B, C, D, E, F, G minus C. So remaining element as a B, D, F, G and H as your V minus C. Now this is considered as another definition of the induced subgraph. But this induced subgraph is by edge. In previous case we induced by vertices. Here we induced by edge. If E is an edge of the directed or undirected graph G equal to VE, we obtain the subgraph G minus E equal to V1 E1 for graph G, where the set of edges is E1 equal to E minus E. So here we subtract the one edge as a small e. The vertex set is unchanged, means V1 equal to V as it is. So this is a given graph, and graph G2 subgraph consider as your subgraph for induced by edge. So here we remove one edge from C to D. So this consider as a induced by edge C to D. So this is a induced by edge. Now next definition is a complete graph. Now complete graph means we can say that an undirected graph in which every vertex has an edge to every other vertex, then it is called the complete graph. Let V be a set of n vertices. The complete graph on V, denoted by Kn, is a loop-free undirected graph where for all the AB belongs to V and A not equal to B, there is an edge A to B. So if two element of the two vertex is as a and B, then if we include A and B in set of vertex, then we compulsorily include the edge A to B. All the possibilities of A to B are available. So we can simply say that from each and every vertex we have each and every vertex connected by each other. So this is called the complete graph. Now here complete graph is like this. Complete graph Kn for k equal to 1, 2, n equal to 1, 2, 3 and 4. So if n equal to 1 means we can say at the k1, complete graph for one node is only one node. Now complete graph for two vertices. So A and B has two vertices. So K2 as a complete graph for 2, n equal to 2. Now for n equal to 3, complete graph is like A, B and C. So all the nodes are connected with each other. K3. Now K4 means complete graph K4 as a for 4 vertices. So all the 4 vertices are connected, directly connected with each other. So this is an example of the complete graph. Now next is a complement of graph. Let G be a loop-free undirected graph on n vertices. The complement of G, denoted by G dash or G bar, is the subgraph of Kn consisting of the n vertices in G and all edges that are not in G. So here we can say that the one undirected graph given is like 4 nodes are there, A, B, C, D, and 3 edges available, A to D, A to B and A to C. Now for the complete graph of the 4 node, we having a complete graph like we have total each and every node connected with each and every remaining nodes, all neighbor nodes. So here we can say that the opposite or complement of the undirected graph is what? So we include all the vertices. So we have a 4 vertices A, B, C, D. So include in complement graph include all the vertices as a B, C, D. Now remaining edges of your given graph is considered as a complement of a graph. So in complete graph, if we include or if we add these two graph, merge these two graph, then this graph become a complete graph. So in first graph, which edges are not available according to complete graph, then add these edges into the complement graph. So here complement graph is A, B, C, D as a vertices, B to C, C to D and B to D as edges. So this is called the complement of a graph. Now last topic of this lecture is a null graph. What is null graph? If G equal to Kn, G dash or G bar is a graph consisting of n vertices and no edges, such a graph is called the null graph. Means we can say that the G equal to Kn means already given graph is a complete graph. Kn graph means complete graph. So given graph is a complete graph, then complement of your graph is not possible. Means we can say that the in complement of graph only vertices are available, no any edge is remaining, because given graph is a complete graph. So this graph consider as a null graph having only nodes, no any edges are available. So this graph is called the null graph. Thank you for watching this video.